My dear students, in this video I am going to discuss about a nature of roots of a quadratic equation. We know that ax square plus bx plus c equal to 0 is a quadratic equation. Its discriminant part is denoted by delta, that is b square minus 4ac. This discriminant part delta is less than 0. We know that b square minus 4a is less than 0, negative. In this case, the roots are imaginary. A quadratic equation has two roots, you know. If delta is greater than 0, that is b square minus 4ac is positive, then the roots are real and distinct, you know. And if delta is equal to 0, that is b square minus 4ac equal to 0, then the roots are real and equal. If delta is greater than 0, the roots are real and distinct. If delta is equal to 0, the roots are real and equal. And in these two cases, the roots are real. But in the third case, if delta is less than 0, negative, b square minus 4ac, the discriminant part is also negative. In this case, the roots are imaginary. The roots are like that. That the roots are alpha plus I beta and alpha minus I beta, where alpha beta are real numbers. These roots alpha plus I beta and alpha minus I beta are called imaginary roots of the quadratic equation if the discriminant part is negative. From this we can see the imaginary roots are occur in pair. The imaginary roots are occur in pair. Imaginary roots are occur in pair and they are conjugate to each other. And they are conjugate to each other. Conjugate to each other. Example, if 2 minus 3i is a root of a quadratic equation, if 2 minus 3a is a root of a quadratic equation, then 2 plus 3i is also a root of the same equation. Also, 2 plus 3i is also a root of the same equation. This is the nature of the imaginary roots. Okay? Now, we are going to solve one problem in the exercise 3.2. Problem number 3. Find the Moning polynomial equation of minimum degree with rational coefficients. Its one root is 2i plus 3. We find the Moning polynomial equation of minimum degree. Its one root is 2i plus 3. Moning polynomial means the minimum degree is 2 and its coefficient is 1. Moning polynomial means the degree of the coefficient of the degree of the polynomial is 1. If one root is 2i plus 3, therefore the other root is, the other root is minus 2i plus 3. See, conjugate roots, they are conjugate roots. Imaginary roots are conjugate to each other. That means the imaginary part of the sign should be changed. 2i plus 3 minus 2i plus 3. Or otherwise you can write it as this is 3 plus 2i. If you write this equation as root as 3 plus 2i, therefore the other root is 3 minus 2i. we can rewrite this 3 plus 2i, 3 minus 2i. These are the same roots. Describing these, having these roots, we have to find out the equation of the minimum degree. For that, we first find sum of the roots. Sum of the roots 3 plus 2i plus 3 minus 2i. In this case, 2i minus 2i get cancelled, you will get 3 plus 3 is 6. Plus 2i minus 2i get 0. 3 plus 3 is 6. Now product of the roots. Product of the roots is 3 plus 2i into 3 minus 2i. So a plus ib into a minus ib, you know from algebra. A plus ib into a minus ib is a square minus b square. A square is 3 square minus b square is 2i square. A square minus b square. B is 2i. Minus 2 a plus ib into a minus ib is a square minus b square. A square minus I square 2 square. You 2i the whole square is I square 2 square. You get 3 square is 9. I square you know minus 1. I square is minus 1. 2 square is 4. So minus of I square is minus 1, minus I square is minus or minus plus 1. Therefore you get 9 minus plus 4. That is equal to, what is that? 13. Product of the roots is 13. Sum of the roots is 6. Product of the roots is 13. Therefore the required equation is required equation with rational coefficient of minimum degree. Therefore the required equation is x square minus sum of the roots into x plus product of the roots equal to 0. X square minus sum of the roots 6x 6 into x plus product of the roots is 13 equal to 0. X square minus 6x plus 13 equal to 0 is a required equation. In this case, the roots are imaginary. For that, we have to check whether b square minus 4ac delta is less than 0. What is b square? Minus 6 square. B square minus 4. A is 1. C is 13. This is minus 6 whole square is 36. Minus 52. 36 minus 52 is 16. Minus 16. So it is less than 0. So delta b square minus 4 is less than 0, so that the roots are imaginary. That's why the equation having imaginary roots which are 3 minus 2i and 3 plus 2i. Okay? Next we will see irrational roots. Irrational roots of a polynomial equation. Suppose p plus root q is an irrational root of a equation or polynomial equation. Roots of an equation. If p plus root q is an irrational root of an equation or polynomial equation, where p and q are rational numbers. P plus root q is an irrational root, where p and q are rational numbers. But p plus root q is an irrational root. As in the case of imaginary roots, p minus root q is also a root of the same equation. If p plus root q is an irrational root of an equation, then p minus root q is also a root of the same equation. As in the case of imaginary roots, irrational roots are also occurring there, and p plus root q and p minus root q are irrational roots. In this case, p plus root q and p minus root q are irrational roots, but p and q are rational numbers. So you consider this note, if root p plus root q is a root of a polynomial equation, since here I am taking both root p and root q. Root p and root q are both are irrational numbers. Root p root p and root q both are irrational numbers. If root p plus root q is the root of a polynomial equation where root p and root q are irrational numbers, then we can also find three more irrational roots, which are root p minus root q, minus root p plus root q, minus root p minus root q. So totally four roots are there. What are they? Root p plus root q, root p minus root q, minus root p plus root q, and minus root p minus root q are the four roots of the same polynomial equation. Okay? Now we are going to solve one problem using irrational roots in exercise 3.2. Problem number 4 is find a polynomial equation of minimum degree with rational coefficients having root 5 minus root 3 is a root. That's the problem. Find a polynomial equation of minimum degree with rational coefficients having one root of that equation is root 5 minus root 3. We know that by our previous note, since root 5 minus root 3 is a root 5 plus root 3 is also a root of the equation. Since root 5 minus root 3 is one root, therefore root 5 plus root 3 is also another root. Further, minus root 5 plus root 3 and minus root 5 minus root 3 also are roots of the same equation. Because the irrational roots having four roots, you know. From the previous note we know root 5 plus root 3, root 5 minus root 3, minus root 5 plus root 3 and minus root 5 minus root 3 are the four roots of the given polynomial equation. First, we will find out the equation whose roots are root 5 minus root 3 and root 5 plus root 3. We are going to find out the first equation whose roots are root 5 minus root 3 and root 5 plus root 3. You know that x square minus sum of the roots into x plus product of the roots equal to 0. X square minus sum of the roots root 5 minus root 3 plus root 5 plus root 3 minus root 3 plus root 3 get cancelled. You will get minus root 3 plus root 3 get cancelled. You will get root 5 plus root 5 2 root 5. X square minus 2 root 5 into x plus product of the roots a plus b into a minus b is a square minus b square. A plus b into a minus b. Algebra result. Root 5 square minus root 3 square. Root 5 square is 5, root 3 square is 3. 5 minus 3 is 2. Therefore, x square minus 2 root 5x plus 2 equal to 0 is the equation whose roots are root 5 minus 3 and root 5 plus 3. Root 5 plus root 3 and root 5 minus root 3. Similarly, we are going to find out another equation whose roots are minus root 5 plus root 3 and minus root 5 minus root 3. So far we have determined an equation x square minus 2 root 5x plus 2 equal to 0 whose roots are root 5 minus 3 plus root 5 minus root 3 plus root 5 plus root 3. See, the first equation number 1 is an equation x square minus 2 root 5x plus 2 equal to 0 whose roots are root 5 plus root 3 and root 5 minus root 3. Similarly, we are going to find out another equation whose roots are minus root 5 plus root 3 and minus root 5 minus root 3. Other two pairs, other two roots. The equation whose roots are minus root 5 plus root 3 and minus root 5 minus root 3 is x square minus sum of the roots plus product of the roots equal to 0. X square minus sum of the roots root 3 minus root 5 plus root 3 minus root 5 minus root 3 plus root 3 minus root 3 cancel. You will get minus root 5 minus root 5 is minus 2 root 5 into x plus product of the roots a plus b into a minus b. A square minus root 5 square minus b square is root 3 square. So x square minus of minus plus 2 root 5x plus minus square is plus root 5 square is 5 minus root 3 square is 3. Again 5 minus 3 is 2. So x square plus 2 root 5x plus 2 equal to 0 is the second equation whose roots are minus root 5 plus root 3 and minus root 5 minus root 3. So combining these two equations 1 and 2 gives you the required polynomial equation consisting of all the four irrational roots. Therefore, the required polynomial equation is product of 1 and 2. X square minus 2 root 5x plus 2 into x square plus 2 root 5x plus 2 equal to 0. Multiplying each and every term, x square into x square is x power 4 plus x square into 2 root 5x is 2 root 5x cube plus 2 into x square is 2x square. Again multiplying minus 2 root 5x with every term, minus root 5x into x square is minus 2 root 5x cube minus 2 root 5 plus 2 root 5x, this minus into plus minus, 2 into 2 4, root 5 into root 5 is 5, x into x is x square. Minus root 5 into plus 2 root 5 is plus into minus minus, 2 into 2 4, root 5 into root 5 5, x into x is x square. Similarly, minus 2 root 5x into 2 is minus 4 root 5x. Again, plus 2 into x square is 2x square, plus 2 into 2 root 5x is 4 root 5x, plus 2 into 2 is 4. Multiplying it in every term, you will simplifying, you will get x power 4 plus 2 root 5 cube and minus 2 root 5 cube, it cancelled. Similarly, minus 4 root 5x plus 4 root 5x are also cancelled, which are in opposite sign. Therefore, x power 4 plus 2x square minus 4 5s are 20x square, again plus 2x square plus 4 equal to 0. By simplification, x power 4, 2 plus 2, 4x square minus 20x square is minus 16x square plus 4 equal to 0, which is the required polynomial equation having all the 4 irrational roots. That's all about the problem, and I will stop my video here. We will continue in the next video. Thank you.